A tennis ball of mass 56 gram is traveling at 1500 meters per minute, which expression is equal to the kinetic energy in joules of the tennis ball. So it will be half into mv square.
Yes, mv square. So you converted, you gave B, right? You converted
Yes, sir.
the gram in kg, right?
Yes, sir.
But you did not convert minute to second.
Oh,
So
yes.
do it now. Do it correct here in your exam paper, huh? Topical mock exam paper. You have printed this page, right?
Yes, sir.
So there you correct it. 1500 divided by 60. It should be how much? Calculate.
25.
25. Then what is your answer coming now?
It should be A.
So it's clear, right?
Yes, sir.
Now
So it should be
19.
always in meter per second
Yes,
because they are the SI units.
here, here we are converting to joules, right? They
Yes, sir.
they are asking you to convert in joules. So if you want to get in joules, all the things should be in SI because joule is the
Oh,
SI unit of
yes.
energy.
Yes, sir.
So here you got 17. Now 19. 19 you gave Bangladesh. 19
Yes,
you
sir.
gave Bangladesh. Let us see the question. You gave Bangladesh, right? Can you read the question?
An extremely large increase in pressure is needed to compress a liquid. A gas can be compressed by a much smaller increase in pressure. Which statement explains this? A. Molecules repel each other very strongly when very close. B. The attractive forces between molecules are small at large distances. C. The molecules in the gas collide with the walls of their container and rebound. D. The molecules of a liquid are constantly moving at random.
So we have extremely large pressure, right? Large increase in pressure
Yes.
there to compress a liquid. A gas can be compressed by a much smaller increase in pressure. So if you are compressing a gas, that means you are decreasing the volume, right?
Yes.
And
Yes.
and if you are decreasing the volume, that time molecules repel each other very strongly when very close, right? Hello?
Sir, molecules doesn't repel each other. Like repel is between like two magnets or like that, right?
Yeah, yes, yes, correct. You are correct about magnet. Now about the molecules. What you gave Bangladesh, right?
Yes, sir.
What you wrote, the attractive forces between molecules are small at large distances. So they are actually asking about increasing pressure. So increasing pressure, how it's increasing pressure? You have to think that way.
Oh, yes.
Hmm. And another one is given the molecules in the gas collide with the walls of their container and rebound. The molecules of a liquid are constantly moving at random. So option D is always happens, right? The
Yes.
molecules of a liquid are constantly moving at random. Now we have left C and A, right?
Yes. CNA.
So C will be C looks like more appropriate, right? If hello,
Yes, sir. Like C is related to the pressure thing.
yeah, C is related to the pressure thing. So if you have decrease in volume, then gas molecules they are colliding with the walls more, right? If they are colliding more,
Yes.
then they are increasing or applying more force per area, right? which
Yes,
is
sir.
which is increasing the pressure. So C is more appropriate, right? Isn't it?
Yes, sir. But B and D are also like correct. They are
B,
not
B,
wrong.
B and D statement is correct, but this context, which one is saying increasing pressure? With that one, which one is more appropriate? We have to pick that one, isn't it?
Oh, yes, sir. Yes.
Your statement is not wrong. B and Bangladesh and Dhaka statement are correct, but in this context, which one we should take? That one is our concern, right?
Yes, sir. Now I get it.
Yeah.
Like with relative to the question, we are going to pick the answer.
Yes, yes. Okay, now 20. Okay, let's see which one you did wrong. You did wrong in 24, right? 24.
Yes, sir.
24, let's see. 24 is A, right?
Yes, sir.
24 is A. So you gave A.
Yes, sir. I gave A in
And
24.
what should be the answer? Did you think?
I don't know, sir. I think it will be A, but there must be some mistake.
You did not
Uh,
understand the mistake yet
no,
of
sir.
options.
Yes, sir. I didn't understand this.
Okay, let us see the question then. 24, right?
Yes,
Okay,
sir.
can you read the question?
The heater is designed to radiate thermal energy. Which change in design decreases thermal energy emitted by radiation? A darker colored surface, a higher surface temperature, a larger surface area, a shinier surface.
So they are saying decreases the thermal energy radiation, right?
Yes,
We
sir.
know we know that any object if it has a darker color, like black body has most, but if it even use a darker color like deep green or deep any other colors you are taking,
Yes,
that
sir.
color will absorb heat more or radiate heat more, right?
Yes, sir.
And the shiny things will reflect more, isn't it? Shiny
The
things,
white things will reflect more.
yeah, white
The
shiny,
whiter surfaces.
white shiny things they are reflecting more. White and shiny both.
Oh, white and
Yeah, white and shiny
yes, sir.
both they are
Reflect.
reflecting back more. And when they are reflecting back, that means they are not radiating, right?
Yes,
Like
sir.
one black thing, it can radiate more. But if you are giving the surface color is shinier, then it will prevent the radiation right outside. It will reflect back in the body again,
Oh,
isn't it?
yes, sir. Yes, sir.
Now your
Y-
surface area, surface temperature, and color, if you are thinking all of this, then they are increasing the thermal energy radiation, right?
Oh, yes, sir.
Only
More
shinier
so.
surface, it is decreasing the thermal energy radiation.
Oh, the answer will be Dhaka.
Yes, now you understood.
Yes, sir. Now I get it.
You got it now. Then we have next. So in your paper, you should take this notes what we are discussing, right? That will be
Yes, sir.
that will be a
Beneficial.
good note for you to revise later. Otherwise,
Yes,
you'll
sir.
forget. Then 33 we have, right?
Yes, sir.
33 you gave Bangladesh. Let us go to 33.
At first, I skipped this question and then I returned to it to like find the answer.
Okay, let me open the structured part also so that we can go it quickly because it's taking some time to open, right?
Yes, sir.
Let me keep it open. Okay, now uh, the information given. Can you please read? Is the
Yes, sir. A motor is used to lift a load of 0.50 meter vertically as shown. The load weighs 40 Newton. The power of the motor is 20 watts and the system is 25% efficient. How long does it take to raise the load?
so what is the formula?
mgh, potential
Yes.
energy.
mg mg is your weight, right?
Yes, sir.
So mg weight you can write directly mg 40 Newton, right?
Yes,
40
sir.
Newton is
Yeah.
your mg and your
Mhm.
height is 0.50 meter.
Yes, sir.
So a motor is used to lift a load of 0.50 meter vertically, load of
Yes,
40
sir.
Newton. So,
Yeah.
so what is your work done here? 20,
Work done 20 Newton. No, 20 watt.
20 joules.
Yes, sir. 20 joules. How are you saying 20 joules?
Because Newton meter is joules. If you have
Newton.
force,
Yeah.
you have weight, right? Weight
Yes,
is
sir.
one kind of force. So force into distance moved, Newton meter. And also, mgh. Mgh is gravitational potential energy, right?
Yes, sir.
That is also joules. In many ways, you can say it is joules.
Oh.
Is it clear?
So the yes, sir. So like the power of the motor is 20 watts. It can be also said as 20 joules.
No, that one is joule per second.
Uh, oh.
20 joule per second.
Oh. Then it's like you're saying about the work done 40 into 0.5. which is 20.
No. We are saying first about work done we found. Okay, we keep it over there, right? This is our useful work done, right? Isn't it?
Yes, sir. So
Now
the
we are
20 watt is the useful work done.
yeah 20 joules, 40
Sir, how did we get 20 joules?
40 Newton multiplied by 0.50.
Oh,
Isn't it 20?
yes, sir. Yeah.
So this one is our useful work done, right? Or useful energy output, we can say, isn't it?
Yes, sir.
So this one
Yes,
you
sir.
keep over there. Somewhere you write it in the space given. This is useful energy output. Now the power of the motor is 20 watt. Okay, and it is
Yes, sir.
25% efficient. If it is 25% efficient, then what is your power output? What is your power output? This is input, right?
Power. Yes,
The
sir.
power of the motor is 20 watt. That means this is your
Yeah.
input. But you are not
Oh,
getting all the things here in your
yes.
purpose. Okay, so
Yeah.
25% of efficient means you will have
Yes.
0.25 multiplied by 20 watt. That is coming 5 watt, right? Isn't it?
Yes, sir. 5
This
watt.
5 watt
So
is
it's
your
like you're using the ratio, right? Like
yes.
useful output energy by input energy. So the input one is 20, so 20 into 0.25,
Yeah,
right?
your efficiency is 25%. That means what you said, that is we are multiplying with 0.25 with the power input, that is giving us output, power output, right?
Oh, yes, yes.
So
So
power
it will be
output
5
is your
watt.
5 watt. Okay, so your power output is 5 watt, you write. Then you write the formula. Power equals energy by time. Are you writing?
Yes, sir. Yes, sir.
Power equals energy by time. Then time equals energy by power, right?
Yes, sir.
If you rearrange,
Energy by
because
power. Yes, sir.
they are asking
We're making
us,
the T the subject, right?
yeah, yeah, because you are asked to find time.
Yes, sir. So it will be
So
20 by 5, which is 4.
4 seconds.
Oh, so the answer will be C.
Yes,
Uh, so they said the power of the motor is 20 watt. So,
yes,
like, how did we understand it's the input, it's not the output? Because the motor is lifting the thing, the
yes,
load.
yes. Excellent. I
So,
like your question. Thank you so much. Because they said the power of the motor is 20 watt and its system is 25% efficient. That means this 20 watt you cannot use everything. Your 75% will be
oh,
lost and 25% will be in work. So with that 25% you are lifting this weight. Okay, that's why this work done you have or the energy transfer you got, that is your energy output. Okay,
oh, now I get it. Like the entire lifting process is not like 20 watt. It's like 25% efficient, but the motor, the equipment motor is like 20 watt
yes,
power
yes.
it's giving. Oh, now I get it. Yeah.
Somehow the energy is lost, right? Somehow the power is
Yes,
lost.
sir. Hmm.
Maybe for frictional, maybe for any other reasons, sound energy or anything, or heat energy, right? It's
Yes,
getting
sir.
lost, right? That power 75%, only 25% is uh, your output. Okay,
Yes, sir. Hmm.
now you got it.
Yes, sir.
It's
Now I
clear now,
understand.
completely clear.
Yes, sir.
Can we go to the next?
Yes, sir. 35.
Yes, 35. 35. What you gave? You gave A.
A, I give.
Let me make it a little bit smaller. Okay, now you can see.
Yes,
Okay,
sir.
now you can see the whole thing. Okay, the whole
Yes,
question
sir.
is visible to you. Can you read the question?
A 100-gram piece of solid lead at room temperature is heated. After 22 seconds, it has all become liquid. The graph shows how its temperature varies with time. The power of the heater is 320 watts. Which expression gives specific latent heat in joules per kg of the lead?
Yes. So, which one you
It will
chose?
be so I choose A
You
over
chose
here.
A. You chose A 7 multiplied 320.
Yes, sir.
Then 0.1 multiplied by 300.
Yes, sir.
Okay, 300 you got their temperature, right? So
Yes, sir.
they,
From the graph.
yeah, so they are asking you about specific latent heat, isn't it? What is the formula of
Yes, sir.
specific latent heat?
E by M del theta.
Again say, again
E
say,
by M del theta.
A by m del theta or Q. How you?
Sir, specific latent heat. Oh, no, that is specific heat capacity. I got confused. Oh, that will be ml, right?
Yes, 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 yes.
Oh, yes.
So it should be L, right? They are asking about
Yes, sir.
specific
To
latent
find
heat.
the L.
You have to find the L. L should be Q by M, right?
Yes, sir.
Q is your heat energy, right?
Yes, sir.
So that one is coming here. Q is coming by multiplying 7 and 2320, right? That means uh,
Yes, sir.
that means time multiplied by power is giving you the energy. And the mass
Yes.
is your 100 gram, that is 0.1 kg. So it's which one now? What should be the answer?
Then it should be C.
So you got messed with the formula, right?
Yes, sir.
So specific
Yes.
latent heat will not have temperature. In the
Oh,
formula,
so here.
it does not have
Mhm.
any temperature, right? Temperature change. Temperature change will be
The
specific heat capacity, right?
Sir, what's the difference between a specific heat capacity and a specific latent heat? Like, what
Yes,
is their difference?
yes, very good question. So specific heat capacity, before going to specific heat capacity, we should understand heat capacity. What is heat
E-
capacity? Heat
It
capacity,
is the energy needed to raise the temperature of a substance by 1 Kelvin.
yes, very good. It is for one object, right? Then if we
Yes,
say
sir.
specific heat capacity,
So it has the same definition, but it will have mass in it. Like,
yes, that is for 1 kg object, right?
yes, sir, 1 kg object.
That is specific heat capacity. And latent heat is the heat required to
Heat
melt,
required to
melt.
melt. Yes,
And
sir.
during melting the temperature remains constant. We are
Yes,
giving
sir.
we are giving heat.
Mhm.
Heat is given, but temperature remains constant. That's why we are saying it latent heat. Latent means hidden heat, right?
Oh, like, sir, a hidden heat. I didn't quite get it. Like, the heat is not the temperature is constant, but the heat is going, right?
Yes,
Because they
yes.
are breaking the potential energy, the
Very good.
bonds there.
Yes, yes. Because they are now stating the yeah, changing the state, right? From
Yes, sir.
from solid to liquid or liquid to gas is going, right? Isn't it?
Yes, sir.
So
Yes, sir.
we can have two kinds of latent heat. One is latent heat of fusion, another one is latent heat of vaporization. In both the cases, we have temperature remains constant. Okay,
Oh, yes, sir.
so
So
we are
vaporization and the fusion, they are the like a object can have both of them like the same heat, with the same temperature, right?
yes, yes, yes. Like if you think of
Yeah.
latent heat of fusion, for example, your ice is converting to water, right? That is latent heat of fusion, 0 degrees Celsius. The temperature remains
Yes,
constant.
sir.
And
Yes,
when
sir.
the water turns to vapor, again temperature remains constant, but the temperature is now 100 degrees Celsius, right?
Yes, sir.
So in
Yeah.
both the cases, we have temperature remains constant. That's why in formula or definition, we are not taking the temperature. Just we are taking the heat energy
Oh,
required.
oh. So because they stay this constant, that's why like we don't like take the temperature, but like they like refer to like the same thing, right?
Hmm.
Oh,
Is clear now?
yes, sir. Now I understand.
So latent heat, why we are saying it latent heat? Because temperature
Because the
remains
heat is
constant.
hidden.
Yeah, hidden heat, temperature remains constant. Okay,
Yes, sir. Yes, sir.
so it's clear now.
Yes, sir.
Okay, now your answer should be C, right? Then
See, yes.
next after 35 we have 36.
Thanks. Yes, sir.
36 you have which one? A you gave. Let's see what is
Yes,
given
sir.
in A. Okay, this one. Can you read it?
Yes, sir. Two liquids in glass thermometer are almost identical. They contain the same quantity of the same liquid and the diameters of their capillary tubes are the same. The only difference is that one thermometer is longer than the other, which row shows how ranges and the sensitivities of the thermometers compare.
Oh, oh, okay. It's gone, right? I'm opening again.
Yes, sir.
So
I just read it from the printed sheet of
okay,
mine.
I just had a click here mistakenly, then it's gone. Let us open
Oh,
again. Here it is, right?
yes, sir.
So what do you think? Where you did mistake? You gave
So,
A, right?
yes, sir. Sir, the reason why I gave A is that one thermometer is longer. If it is longer, then it will have more range. And if a thermometer has more range, it will be like less sensitive. Now, yes, it will be less sensitive. So like both of them becomes different,
Yeah,
right?
yeah. Look here, there is one thing given here: capillary tube. Their capillary
Oh,
tube is
yes,
having the same diameter, so we have to actually focus there also. If you have the longer one, uh, if the longer one has narrow capillary, that time you can
is
say its
uh,
sensitivity is more. But if you have the
oh,
same diameter, then with what is the definition of sensitivity? Sensitivity means the increase of the liquid thread. Okay, with every degree Celsius,
oh.
that one
Sir,
is
can
showing
you say
is,
it again?
yeah, the increase of liquid thread or liquid level with every degree Celsius is known as sensitivity of the thermometer, right? Like you are getting
Yes, sir.
two thermometers. If you are increasing 1 degree Celsius temperature, then one is increasing 1 centimeter, another is increasing 2 centimeter, the liquid thread. Okay, so the one which is
Yes,
increasing
sir.
2 centimeter, that is more sensitive.
Yes, because it is increasing more
Yeah,
compared to
that is
the
called
other
more
one.
sensitive, right? Now, if
Yes,
you
sir.
think about these two thermometers, if you increase 1 degree Celsius, even if one is longer, another one is shorter. For every degree Celsius increase in temperature, their ratio of increasing the liquid thread will be same, right? Isn't it? As their
But
capillary,
how? Because like one has like more calibration, right? So it will
yes,
like move more.
yeah, that will move more if you are increasing temperature. Like for example, after increasing 30 degrees Celsius, then your one thermometer is completely done. That does not have any more liquid to increase, right?
Oh,
Another
yes.
another one after 30, you have now space, that one can increase. So it does not mean that uh, it has the capacity more. That's why it is increasing more. It's already done. Like every degree Celsius,
Oh,
you saw that they are increasing same way. That's why we will say they are more sensitive because their capillarity is same. They are identical
so
thermometer.
sensitivity is related to the diameters of the capillary tube rather
Not
than like the
not
length
o-
of the.
not only not only diameter. It's also depending on the uh, you see. It's also depending on the larger bulb. Okay, then it's
Oh,
also depending on the nature of the liquid. Some of the liquid, they can expand more with 1 degree Celsius temperature rise. So they are more sensitive. Is it clear? Hello?
yes, sir.
So sensitivity is related to larger bulb, narrow
But
capillary,
then, yes,
and
and
another
the
one is
nature of the
like,
liquid.
yeah, nature of the liquid, which is expanding more with the same degree Celsius temperature rise. That one is more sensitive, right?
Yes, sir.
Also we have you know, this range is also sometimes affecting the sensitivity if you have different diameter, not identical thermometer. Okay,
Yes, sir.
if the
Yeah.
thermometer is not identical, that time also it's working. Like if you are taking a thermometer or of a big range is from 100 degree to 300 degrees Celsius. You are taking one thermometer. Another
Yes, sir.
thermometer you are taking only 30 degrees Celsius. So if you increase your temperature for 1 degree Celsius, that then you will see that 30 degree one, the increase in length of the liquid thread will be
More.
more. But the
Yes, sir.
200 one, which one has range, that one will see a little bit increase for 1 degree Celsius, right? In that case,
Yes, sir.
the smaller range one, it is more sensitive. Is it clear?
Yes, sir.
So
So
this,
because of the diameters, the sensitivity will remain same, but the ranges will differ,
yes,
right?
range will be different. Range will be different. It's clear now? 36.
Sir, like what things does what factors are like ranges depend on? L-
Yeah, ranges
Yes.
depend on the also we can say range. Uh, if you are taking liquid uh, expansion, which one has more expansion, right? So that type of liquid
Yes, sir.
cannot have bigger range, but the liquid which has a little bit expansion, that one can measure more temperature, like high temperature it can measure. Is it clear?
Oh, so like less expanding liquid will have more range.
More range, correct. You got it. You understood it now?
Yes, sir. Yes, sir. Now I understand.
Okay.
Then, sir, 37. It will be B then, right, sir?
Which one? 36.
The 36. Yes, sir.
Yeah,
It will
Bangladesh.
be B.
Bangladesh.
And then, sir, 37.
37, what you gave? You gave C.
Yes, sir.
What is 37? You gave the capillary tube is long. What make a clinical thermometer suitable for measuring small changes in body temperature?
So the thermometer should be more sensitive to measure the small changes, right?
Yeah, more sensitive. That's why the capillary tube uh, is long, or the bore
So
of
it
the
will-
capillary tube is no narrow. Which one should be the more appropriate one?
Uh, sir, bore, sir,
Bore means
what is the
diameter,
bore, sir?
diameter.
Diameter of the like the capillary tube.
Yes. Bore is diameter.
Oh, oh, meter of capillary tube. Then, sir, capillary tube is long, but it will not be more sensitive because it should be like narrower, right?
Yes,
So it should be B.
it should be Bangladesh. Yeah, 37 should be Bangladesh.
Yes, sir. Now I understand it. Because of like if it's narrow, it will be the range will be more, but the sensitivity will not be affected.
Yeah. So here our focus is sensitivity is by 1 degree Celsius temperature rise, which one has more liquid thread? That is more sensitive, right? This
Yes,
should be
sir.
your focus. Always focus there, then you'll get all the ideas. Any context you think, you'll get the correct ideas. Okay, done?
Oh, yes, sir.
Now we are done with MCQ part. We'll go to
Yes, sir.
structured part now. Structured part here I opened, and your paper also need to be open. Oh, structured part you have the paper altogether. Everything is there.
Yes, sir. Yes,
That's
sir.
why we can directly see it from there. So you got lots of ideas today, right?
Yes, sir. My confusions are cleared, like lots of confusions.
Okay. Alhamdulillah. Okay, so you gave
Yes, sir.
it horizontally. This one.
Vertical.
So in your MCQ part, you write that, huh? What I wrote here, 32 out
Oh,
of,
yes.
write that
So,
quickly.
so marks obtained, I will write, right?
Yeah, yeah. Marks of it you write 32, then slash
Yes.
40. Give a circle, then you write beside 80% and write today's date. Today we checked it, right? So write today's date. So have you written?
Yes, sir. Sir, the screen share is gone.
Oh, because it was disconnected for a while
Oh,
because of the network problem. Okay, now came, right?
yes, sir.
So the first one you give a tick, huh? Quickly, huh?
Yes, sir. So done.
The second one also tick, huh?
Okay, sir. So
Eight
third
four
one.
zero zero 840. Let me check the next one.
Okay, sir.
Oh, so it is coming 167 meter per. Yes, it is also correct. Give a tick here.
Okay, sir. So I'm obtaining the full marks, right?
Which one?
Like 2 out of 2 in the third part, right? 2 out of 2.
Yeah, yeah.
Even though like I gave in decimals, but
No,
it's okay, right, sir?
yeah, decimal. It should be. Yeah, actually, the answer should be in normally what we practice. That is either in two or three significant figures. So you can write it
Okay.
167. Okay, you
Yes,
can
sir.
write it.
This.
But if you write it this way, no problem, as they did not clearly mention it that you have to write in three significant figures. That's why it's okay
Uh,
how you wrote, no
mhm.
problem. And last
Okay,
one,
sir.
suggest one is why the speed determined v is less than the actual speed, and it is slowed down as it comes to Earth's atmosphere. So we calculated, we calculated it from here, right? Thermal energy, right?
Yes, sir. Yes, sir.
This thermal energy we are getting, and from that thermal energy we are calculating the speed. So the problem was there because when we found the thermal energy, that time we miss some amount of energy from there, because some energy is lost in the surroundings. Okay, hello.
Sir, sound energy, like how? Sir,
Some
my
I
one, the logic is right, sir?
Yeah, your logic is right, but you think more deeply, because we are now directly getting this kinetic energy from the
Yes, sir.
information given. You see, in the question, the information given, if you check out that, then it's not there anywhere written that the speed or kinetic energy is this. They only gave you the information about
Oh,
thermal energy, right? So
yes,
your
sir.
thermal
Yes.
energy you got from this data, that is given less. Why less?
Oh,
Because some energy is lost in the surroundings as the form of sound or as the form of heat energy in the surroundings, isn't it? That's why
yes, sir.
our calculation was low there or less there, and for that consequence we had here the kinetic energy, it is less, isn't it?
Our kinetic energy is less, or the actual one? The
Yeah,
actual
our
one is
our
less. Right?
our calculation one is less. Actually, what is happening, the object is falling and hitting, uh, it's hitting the stone or ground, anything, right?
Yes, sir.
So when it is falling and hitting something, that time some energy it is lost, right, in the surroundings. So the
Yes,
actual
sir.
actual internal energy you are not getting here, isn't it? then
Oh,
then
yes,
as you are
sir.
not getting the actual internal energy, that's why your kinetic energy calculation also becoming less. Is it clear?
Oh, yes, sir.
So
Yes.
the that point we should bring here in our discussion, that is
Oh,
some energy is lost to ground, okay,
yes, sir.
or in the surroundings.
Oh, yes, sir.
So that should be our point here. So you give your minus
Oh,
one, eh?
yes, sir.
Then
Yes.
next is our question two, right?
Yes, sir. The radiation.
State how energy from the sun travels to the space before it reaches by radiation. It does not need any medium. Okay. Explain the advantage of using panels that have a black cell. Black cells are good absorber and emitter, so therefore from the sun faster and release them to heat up the pipe faster. Okay, here mainly our concern is the solar panel. Why it is black? It is absorbing
Yes,
more
sir.
heat energy, right?
Yes, sir.
Absorbing black surface is good absorber of radiation, so more energy will be absorbed, right? And if you
Yes,
have
sir.
more energy, you can produce more electricity, right?
Oh, yeah.
So that is the point should come here. We should write that black surface are good absorber, so it can absorb more energy and can produce more electricity. To produce more electricity, there is second mark, and it's a good absorber
Oh,
of it. There is first mark. So you mentioned that one. It can produce more electricity. Emitter one will not come here. Okay.
oh,
It
yeah.
is true that black is good emitter, but in this context The absorber one will come and it can produce more electricity. That is your second mark. So give your -1.
Oh, yes, sir. Yes, sir. So it will be, it can produce more electricity because it
Yes.
can gain more kinetic, more energy.
More heat
Um,
energy. Okay, from the sun.
yes, sir.
So you got here
360 joules.
360 joules, and joules is the unit of energy, right? And you got here power. P equals V into I.
Oh,
You have
oh.
1 hour. To get that energy, you should multiply with time also. Then you multiply it with 1 hour, that is 60 seconds. It will give you energy. Okay? Then you write here energy equals P into T. Okay, as you already wrote this, and do the next step.
Yes,
E
sir.
equals P into T. Then your T is 1 hour 60 seconds. Then you are getting how much? Check.
So it will be 16 to 60.
360 into 60. Yeah, that one 360 into 60 into 60. 3600.
Yes, sir.
1 hour.
1296000.
1296. Yes, yes. So you can write it 1.3 into 10 to the power 6, right?
Yes, sir. Yes.
1.3 into 10 to the power 6 you can write. So we stop here, huh?
Yes, sir.
So we will start 5:45. Okay. Hello.
Okay, sir.
Thank you.